the graph of g of x is the image, so the blue graph is the image of the graph of f of x, which is the red one, after a bunch of transformations. We want to write and then verify an equation. So what we know, based on the picture that's drawn, they've got a point A and a point B, and they said where A goes is A prime and where B goes is B prime. So what we know is we can say, I know that A was at 0, 8. A bunch of things happened, and then on the blue graph, oops, that's not blue, we get -2, 0. And point B, which starts at 2, -8, a bunch of things happen again, and it ends up at 0, -8. And what you could do next is you could just guess and check a bunch of things and see if something works. Okay? But the problem with guessing and checking is sometimes nothing works for a very long time. So this is where we have to use that second strategy that I showed you yesterday. Okay? We're first going to figure out the stretches and compressions by comparing horizontal distances and vertical distances. So if I look at my horizontal distances, from A to B, I'll write that one in red, because that's my red graph. My original graph from A to B, I am going 2 units to the right, so I'll write that as a +2. Then I go to my blue graph, and check what happens if I go from A prime to B prime. It's also 2 units to the right, which means nothing's happened horizontal. You're x by 1. I wouldn't even, like, you don't have to do anything for horizontal, because you're multiplying by 1, nothing's changed. But when we look at our vertical distances, that's pretty. When we look at our vertical distances, from A to B, I go from 8 down to -8, I would write that as a -16, because I'm going down. When I go from A to B vertically, it goes down 16 units. Right? From A straight down to B is down 16 units. From A prime to B prime, the y value starts at 0, goes down to -8, it goes down 8. This tells me that I have a vertical compression. My y values have been multiplied by 1/2. And once you have that, we just figured out what should go above these first arrows. You don't have to write, I mean, you can write x by 1 if you want, but you don't need to write it because nothing's going to happen. Your x values stay 0 and 2. But your y values have to get cut in half. So that means the 8's going to be a 4, and the -8 is going to be a -4. And once you have those 2 middle points, then you're going to be able to tell me quite easily, does it go left or right? By how much? Right? You're going from 0 to -2. That sure looks like 2 to the left. Does it verify and does it work for the second one? Yes. What about the y values? You go from 4 to 0, that sure looks like 4 down. Verify it. Does it work for the second one? Yes. So we can now write the equation. It says, write the equation for the image graph in terms of the function f. Now you have two options. The image graph is the blue one. The blue one is already labeled as y equals g of x. So when we write our equation, on the left-hand side, you could either write y or you could write g of x. On the right-hand side, because it says in terms of the function f, we need f of x on the right-hand side. Well, what are all of our transformations? We have a vertical compression by a half. That would show up outside the function. 2 to the left would show up inside the function. 4 down, outside the function. So here's the equation in terms of f. And this part right here, by writing the points like we did, we actually verified it already. We already showed that it worked. So our method also was a verification at the same time, which is kind of nice. So we need to use this when there's a bunch of them, you need to figure out your stretches and compressions first. That gives you those 2 points in the middle, and then left, right, up, and down become easy. But without these 2 points in the middle, just trying to go from the red to the blue can sometimes be really difficult. Sometimes you guess and get it right away, but other times you spend a long time looking. Okay, so I'd like you to circle question number 9. And then there's a few more things I want to show you about the online program.